Hey guys, I'm trying to take some notes on paper, so if this video seems weird, it's because right now I have my cell phone rubber banded to like a scissors holder and it's sitting on some books. So hopefully this works until I get my doc cam working. So we are going to deal with piecewise functions is what they're called, and can't really move my paper down. There we go. This is 1.7 piecewise functions, and today I want you to be able to write an equation from a graph. This is my blister that I got while kayaking with the swim team over the weekend, so sorry it's gross. All right, so I'm gonna try and do this so you can possibly read all of it. Okay, here we go. So Brittany traveled at a rate of 30 miles per hour for 8 minutes. So I'm hoping that we can kind of like follow along on this. 30 miles an hour for 8 minutes. So that was this. For 8 minutes, she traveled 30 miles per hour. She stopped at the stoplight for 2 minutes. Stopped. For 4 minutes, she traveled 15 miles per hour in the school zone. Then she sat for 2 minutes while her brother got out of the car. And then she finally went home and she traveled 25 miles per hour. So this is a piecewise function because it has a bunch of different pieces. And our goal here today is to be able to write an equation for a graph like this. And I hope you're noticing like this can't all be one line because it doesn't all have the same slope. So we have a few different lines and we want to be able to write equations for both of them, or for all of them. So I'm gonna make kind of like points where there's some starts and stops. The PDF of this note will be online in case you want to print it off and kind of copy it into your own notes. So if I think about this girl Brittany traveling for 8 minutes at 30 miles per hour, so she is starting at like 0 minutes. She gets in her car, right? So here's my pink. I can write an equation, but I also have to, I'm gonna go down here, think about like the domain of this. So from time equals 0 to time, which is my x, up to and including minute number 8, right? She was traveling at 30 miles an hour. We're gonna call this the domain, meaning what do my x's go between? Well, here you can see in the pink, my x's go between 0 and 8, and I'm gonna include 0 and I'm gonna include 8 in this one. Now I need to write an equation. We can find points on here though, we've been practicing this. So she traveled 4 miles, and I hope you can see that, after 8 minutes. So my x is 8 minutes and my distance was 4 miles. That's my first dot here. And I could also find this dot here, which is 0 minutes and 0 distance. So I can use my slope-intercept form. I'm just gonna write it here. Not slope-intercept, sorry, point-intercept form. To deal with these 2 points. So first thing I should probably do is find the slope. Well, you could count the slope, right? You go over 8, up 4. So let's go 4 minus 0 is 8 minus 0. You get 4/8. So my slope is 1/2. And I'm gonna choose, I don't know, the easy point right here. So y minus, oops, you guys can't see, 0 equals 1/2. X minus 0. Well, that was an easy one. 1/2 x. Okay, and that should kind of make sense, right? Because 1/2 is 30 miles per hour, half an hour, and you started at 0, 0. So now we're just writing equations. Okay, I'm gonna kind of go back up here and read it again, the first blue part. She stopped at the stoplight for 2 minutes. So if I think of this first blue part here, let's first think about the domain. It probably doesn't include minute number 8 because she was driving up to minute number 8. So I'm just gonna say that when time was greater than 8, meaning like 8 minutes and 1 second she was stopped. And she went all the way up to, if you can see on the graph, she went up to 10 minutes. And let's include minute number 10. Because she stopped for 2 minutes, so it would include minute number 10. And this equation is just a straight line. So this equation is just y equals, and did she move anywhere? She didn't. Y equals 4. She stayed at this line 4 right here. You can see at 8 she was at 4, at 8 minutes 30 seconds she was still at 4 miles. She never got any farther away. 9 minutes all the way up until 10 minutes she was at 4 miles away from her house. Then for 4 minutes she traveled 15 miles per hour through the school zone. Okay, so when we do our orange equation, hopefully we can still see here. Okay, she again is traveling, and we could come up with some points here. One of the points on this graph is 10 over 4 up, and I'm getting this right from the graph, and then 14 over 5 up. So these are my 2 points. I'm literally just picking points off the graph because I know if I have 2 points, I can find a slope and I can find the equation. So let's see if I can, without falling off. Let's talk about the domain again. We're starting at 10 minutes. We included 10 minutes last time, so we're not going to include it this time. And she did that for 4 minutes, so we're going to go up to and including the 14th minute, and you can see that's where this one ends right here, is minute 14. Let's find my slope, and I'm going to find my slope using my 2 points, which are, and I'll write them, let's see, where can you see them? Is going to be, let's see, y2, which is 5, minus y1 is 4, and then 14 minus 10, so I get 1/4. Again, 15 miles per hour is a quarter of an hour. And then I'm going to use one of my points, so let's use the point 10, 4. So y minus 4 equals 1/4 x minus 10. Now remember, we do not have to do anything with this. Like this, sorry, this is our equation. You don't have to simplify, you don't have to put it into a different formula or anything. You're just going to leave it like that. So with the little bit of room I have left, sorry guys, remember to pause when you need to. I'm going to try to do the next blue line kind of beneath here, but I need to try to move my pieces of paper up. My blue line was another straight line. Hopefully you remember that. So if I go like this, straight line. It was also at 5 miles an hour this time. And if I put another point here, this would be 16, 5. Okay, so I spent 2 minutes waiting for her brother to get out of the car. So the next blue line again, I was between minute 14 and I stayed in the car until I hit 16 minutes. And this time my Y was at 5. Okay, I was still 5 miles away from home. My last line is yellow. Try to do that just down here. She traveled home 25 miles per hour. So we've got 2 points. I already labeled one, 16, 5, and then this one is 28, 0, because she's 0 away from home. And I hope you notice that here she's going positive slope, right? She's getting farther and farther away from home. Now she's getting closer and closer and closer to home. So we should have a negative slope this time. So I've got 2 points, or let's do the domain part, meaning she starts at 14 and she ends at minute 28. Okay, so that was from my graph. I started at, oops, excuse me, this should be 16. My mistake, 16. So she started at minute 16 up here and went all the way to minute 28. Then my slope, I'm going to use my points. I'm going to take 0 minus 5 over 28 minus 16. I get negative 5 over, I don't really want to do this in my 12, so negative 5/12. So that's my slope, and I'm going to plug it in now to, I'm going to use my easy point, 28, 0. So y minus 0 equals negative 5/12. Sorry, x minus 28. Okay, so you can just leave it right like that. And I have now written an equation for this entire problem. See if I can zoom out for you. Look at this. Okay, so that's our goal today. Can we follow along on a graph and write equations for it? Let me get my next piece of paper here. So I've got another one. This one's a little different, so I'm going to explain the difference here. We got a couple things happening. If I can get this under my books here, so I can write on it. Okay. When you see an open dot, okay, this means less than or greater than. And if you see a closed dot, this means less than, equal to, or greater than and equal to. So this first example, we kind of made up our own mind on like the closed dot, open dot thing, because there weren't any there for us. We said like it started at 8 minutes and 1 second and went until exactly 10 minutes. This time, when I present you with a graph like this, you're going to use these. So the first thing I'm going to do on this one is label my points. So this is -4 plus 1, and then this is -10, -3. Okay, so if I'm going to write an equation, we can make it the orange line here. The orange line has 2 points, so first we find a slope. Or we can do domain first, since that's the way we did it. All of my x's, they start here at -4, and then they keep going this way. So I want all x's less than or equal to -4. I knew this because of this closed dot. Okay, the closed dot tells me less than or equal to. Now I can find my slope. 1 minus -3 over -4 minus 10 minus -10. So you get 4 over 6? So 2/3. Okay, so this one, if I go from one point to the next, it's up 2 over 3, up 2 over 3. So I have slope. Now I just need to give me an equation. So y minus 1 equals 2/3 x plus 4. You could also have used the other point and gotten the same thing. Okay, when I do a line like this, my x is -4, my y is 5, and over here my y is +3, 5. It's kind of even hard for me to read. My x's went between -4 and +3. Oops, you guys couldn't see that. Between -4 and +3. But on this side, it's an open circle, so it just has to be less than. On this side, it's a closed circle, so I need the greater than equal to, less than equal to part of it. Now I can write my equation. This one should be easy because y always equals 5. Okay, let's see. Pink. Let's do the last one, pink. Pink line. Oh crap, you guys can't see that. Pink line is starting at 3, and then it keeps going like forever and ever and ever. So all x's greater than or equal to 3 because I have a closed line. I don't have like a boundary on this side. I tried to make this look like there was an arrow, but you can't tell that there's an arrow. I promise you there's an arrow, and it keeps going forever and ever. So if we could find another point, I also tried to put that in. 1, 2, 3, 4, 5, 6 over, 1 down. Same steps as before. First make a slope. -1 minus 5 over 6 minus 3. Oops, so I got -2 as my slope. And then pick one of your points. Y minus 5 equals -2, x minus 3. Okay, and again, you can leave it like this. Tomorrow in class, this will be your homework. Okay, there's 2 word problems on the back, like the one that we did. So, word problem, non-word problem, and I will have copies of these up online.